everyone. This time we'll keep on study for derivative formula 2. For last session we discovered a lot of derivative formulas, right? So, but I noticed that I did not finish yet. So today I got another 10. So after this, I think the majority still not yet finished, but I think to me it's already enough. So this is the second session. So I have organized totally 10 formulas. So the first formula is dy or fx dy is equal to 1 over dx over dy. Of course, if you just look at this as a kind of what as a kind of what as a kind of only like y, give example, like y over x. Of course, you can write it as what 1 over what x over y, right? That's definitely the same, right? Just this normal algebra, right? But this way it looks in fact similar, right? But it's still working. So I don't want to prove that, but I just want to give example to prove that it's true. Okay, so I make that y equals to x squared plus 1. Okay, it's okay, right? I can make that, right? So dy, so or y prime maybe, okay, is equals to what? 2x, right? X squared is 2x derivative, and then 1 constant is 0, so it's 2x. So let's see, how about 1 over dx over dy? Okay, if they also get the 2x, so definitely they're right? So what is dx over dy? So we have to look at here. So x square plus equals to what? Y minus 1. And then we can deduce x equals to square root of y minus 1, right? So like this one, we can deduce as what? Derivative of what? dx is what? Square root of y minus 1 derivative. Am I right? So this is what? Let me move right side, huh? This is what? This is like 1/2, right? If it's 1/2, what we're doing is like, of course, let me go. Nominator part. We draw 1/2, right? And then what? Y minus 1 what? This 1/2 minus 1 is negative 1/2. Am I right? And then let's simplify this is what? 2, right? And this negative go to positive, so you go to the denominator part. Y minus 1 what? What? 1/2. This will not change, right? So, but y equals to what? Y equals to x squared plus 1, right? So I just move, like, change this one. So it's like a x squared plus 1 minus 1. So it's 2x. Am I right? X squared plus square root, of course, is original 2x. So it is same? Yes, same. So I think, okay, so in this way, we prove is right. So then go to the trigonometric derivative. I will not prove those kind of things because it's a kindly hard and we'll spend long time for that one. But just remember, sine derivative is cosine. Cosine derivative is sine, but it's negative sign at the beginning. And tangent derivative is the second to the second power. Cotangent is the negative cosecant to the second power. Okay, so just give example here. Okay, if like if sine x, if sine we may just x make it 30. Okay, so if like this way, so the finally will be same as cosine 30 degree, right? So for cosine 30 degree is square root of 3 over 2, right? Anyway, when you're asking me why to get this one, I just tell you this is the special angle, right? Special angle 30 degree, 45 degree, 90 degree or something. Normally we can easily draw, right? For 30 degree, what's their sine? 30 is 1/2, right? It's 1/2. So cosine is a square root of 3 over 2, right? Okay, just like this, so easy to get. Okay. So let's give one more example. Okay, if this sine x square times x, how about derivative of this one? X times sine x square. That's a little hard, right? So this is like a multiplication, right? So suppose you should do like this way, right? X prime, then sine x square, and then plus, right? X, then sine x square prime. Am I right? So how this will be looks like? X prime is equal to 1, so this will be sine x square. The second term is solid copy x, and then sine x square should be what? We already know, see here, right? Is cosine x square, right? And that's not finished yet because this is x square, so have to be the derivative again. X square will be derivative. X square derivative is what? 2x, right? So the final answer is what? The final answer is sine x square plus 2x square what? Cosine x square. This is the final answer. Okay, this is the final answer. Then let's go to I saw only 10. In fact, I have 13. Okay, so let's go to this one. Arc sine derivative equals to 1 over 1 square root 1 minus x squared. For this one, I will prove to it. Okay, so how to prove this? I make like arc sine x equals to fx. Suppose, huh? I don't say it is exactly just suppose. It can be, right? Can be, right? Fx can be anything, right? Can be anything. So suppose like this way, right? So what? So derivative of arc sine x, of course, is equal to fx derivative. This makes sense, right? This makes sense, right? Okay, this makes sense. So, but you observe this one, arc sine x equal to fx. We can write in another form like sine fx equals to x. Am I right? Because if you don't feel this right, you think about what is arc sine means, right? Arc sine means exactly this, right? Okay. So what we want to get? We want to get the derivative of fx. Am I right? And since they are the same, so we can derivative on both sides. Am I right? So on left side is what? Sine x is cosine x. So first is cosine fx. Fx have to be prime by itself. Am I right? Fx prime. Okay. And the right side is what? X prime is 1. Am I right? So we can write in as what? We can write in as what? We can write in as fx prime is equal to 1 minus what? Cosine fx. Am I right? Sorry, there's no such things as a square root. Or at least not now. right? So what's this? So it's equals to what? Cosine x equals to 1 minus what? Sine fx square. Am I right? Am I right? Cosine fx can change to 1 minus sine fx, right? This is because of the formula of sine x square plus cosine x square equals to 1. Don't ask me how to prove this, okay? This is not related to our derivative. But if you want, in the future, just give me comment. I will prove that in the future for you, okay? So what about the sine fx square? Sine fx square we already see here, right? Sine fx is equal to x. So this can minus what? 1 minus x square. Let's see if it's the same. Yeah, 1 minus x square, right? So the same way we can calculate it, the arc cosine derivative is equal to negative 1 over square root 1 over 1 minus x squared. So next one, we go to log. Log x, this is a we teach it before, right? This is a called natural logarithm because their base is e, right? So how come this becomes the 1 over x? I will prove this, okay? But the rest I will not prove, but I maybe just give an example, okay, about this one. So how do you prove this one? So we just wait. We just make like 9 x log x equals to y. This is okay, right? This definitely, of course, right? So if you like this way, so we can write in as what? E, right, to the y power equals to x. Am I right? Right? So if like this way, we derivative on both sides, so we can get what? So ey, of course we ey, of course we put y, right? Remember here, ex prime is still ex, so the derivative is still what? Ey, right? But y here, y itself, y lead to prime y because y is equals to, right, log x. So y is not x, right? So y have to be derivative, right? Any for the exponential, if the derivative it's itself, right? And but if the derivative part, if the exponential part, it's the can be derivative by x, so have to be derivative again, right? So this is equals to x derivative is 1, right? So y prime equals to what? 1 over ey, and the ui is to x, so equals to 1 over x. Am I right? Right? Okay. So the same thing happened if the base is a to the x, so they change to 1 over, look here, is a natural logarithm, and a is not base anymore, it's a times x, okay? I will leave you to approve that, okay? If as the base is e, then the derivative is itself, the derivative itself, okay? And if the x, if it is ax, if the just the change the base is not e, in fact so they are derivative will be what? The derivative will be ln natural logarithm a times a to the x power. I will not prove this, but just remember this, okay? For the last one, Last one is talk about log base a to the x is equal to natural logarithm of x divided by natural logarithm to the a. So this one, I will not prove it, but I will just use a real scenario to prove this one, okay? So how do you prove this one? We just make this a equals to what? Equals to what? Because they changed this to ln, so we better make it is as what? Is close to e, right? If it is e, so it will be easy, right? Okay. Uh, uh, wait, ln. Okay, if a equals to e, if and x equals to e square and b, right? So log e square equals to what? Is equal to what? Is equal to okay, let's give example. Log ax equals to y. What's that mean? Which means that a to the y power equals to x. Am I right? Am I right? Okay. So 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 what's this result? Think about it. A. So it should be the 2. Am I right? Because if you change to this one, is e to the second power is e2 square, right? So okay. So so the answer is 2. Let's see if it is same as log n. X is e2 over ln a. Okay. Let's see if it is. This is ln. This is e, right? Sorry, this is e. So ln e2 is 2, right? ln e is 1, right? So it's 2. So they're same. They're same. Okay, right? So today we spend a lot of time to introduce another 13 formula of the derivative. This will be overall my introduce the formula of derivative. And the next time I will introduce the formula of integral. Okay, thank you for your joining and listening. Thank you very much. Have a nice day. Bye-bye.